Okay, we're going to be integrating a problem from the review, and this is the problem we're going to do. It is x secant of x times tangent of x dx. And we're just going to evaluate this integral. Now because I can see there's a little bit of multiplication going on, we'll just do this. We're gonna see it as two separate things like that. We're multiplying x times secant of x times tangent of x. So because of the multiplication, we're going to be using integration by parts. So in order to use that, we need to first use the formula. So number one is, I'm just going to write out what the formula is for integration by parts. We have integrate u du equals u times v minus the integral of v du. Obviously this doesn't really mean anything yet because we need to get some, so we need to address what's going to be what for each part of the variable. So number two, we're going to have u equal x. And I'll explain why I picked x for u in a second, but let's just take the derivative of that, which is just going to be dx, because the if you take the derivative of x, it's just going to be 1. So this is kind of like a 1 in parentheses, but we can just forget about that. So du equals dx, u equals x. So we've got this part, and we're getting rid of the dx, so we have to use du. So we got those two all set. So this one's done, and this one's done. Now I just need v. So the reason I picked x for u is because I can see already that this part right here, secant of x times tangent of x, I can recognize that as the antiderivative of secant x. So we're going to let dv, I'll do it this way, dv equals secant of x, tangent of x, like we had originally, and we're going to take the antiderivative of it, which is going to be secant of x, because we have it all written down. This is something we have in our packet, so we're all set with that kind of thing. So we have our dv and our v, so we're all set. We have everything we need. So all we have to do now is just plug it into the equation. So first things first, let's just write our original x secant of x, tangent of x, dx equals u times v. So we have x times our v, which is going to be secant of x. So we just did this little section right here, multiplied those two times each other, minus the integral of v du. So we're going to multiply, so these two multiplied by each other, minus these two multiplied by each other. So our little triangle we got going. So that is secant of x dx. Okay, so now we just have to solve it. We've done the hard part. We've done everything we need to. Now, this beginning part is pretty easy. So let's do 4. Let's do the original again, just to make sure we're on the right track. Tangent of x dx equals. So we have x times secant of x. That doesn't really change. Actually, it doesn't change. It's not really. And then we have the subtraction of this baby. Now we have to, in order to fulfill this whole problem, we need to take, we need to integrate this little section right here. So it's still going to be a subtraction, but secant of x, if you want to integrate it, secant of x actually equals the natural log of secant x plus tangent x plus c. Don't forget your absolute value signs, and that is coming from this little section right here from our packet. Okay, so all we have to do is plug in secant of x all the way up here. Minus secant of x. Oops, I'm sorry. Secant of x plus tangent of x plus c. So, our whole following problem we're going to bring down here. Final problem equals x secant of x minus natural log plus tangent of x plus c. That is our answer. So we did the integration by parts. We had the formula for it. We just plugged in our variables, taking the antiderivative and the derivative. And then we just plugged in what u and v and du equal. And then for the v du section, we have to take the integral of that, or integrate that section. And since secant of x is what we have over here, dx, we just use our formula that we have in our packet, which is that, plugged in there. That's our answer. Thank you.